So let's say for the first one, 1.80 times 10 to the power of 2. How many significant figures with this one? Significant figures. 0.015, again, the leading zeros here are insignificant. So the significant is just the 1 and the 5. So two significant figure. And then you have 1.01. Again, you have in between two non-zero digit, even though you have a decimal point there. So therefore, you're going to count the 0 as significant. So this is three significant figures. And then 710 meters per second. So the zeros after a non-zero without a decimal there, the 0 here is considered insignificant. So therefore, you only have two significant figures. And then the last one here, the zeros in front. Again, you don't have any non-zero in front here. So all the zeros here are insignificant. So the significant figures are just your 2, 5, and 8. So you have three significant figures. So before we proceed with the next one, are there any questions? You can type. Yes.
For the 710, why is the 0 not significant again?
Can I go 700?
Yeah,
710?
Yeah.
Yeah. The 0 here is not significant because any 0 that after a non-zero are considered insignificant. Actually, in some other books, they say it's trivial. It could be significant or not significant. But we just follow that any 0 after a non-zero, and then you don't have any decimal following it, that would be a significant. Yep.
Okay, cool.
You might read, I know, some books, sometimes they try to make this one as, that's why it's, the zeros are trivial or tricky. Okay?
Yeah.
But we just follow that one, okay? But if you have a 0 after a non-zero, and then you don't have a specific decimal point, we will not consider that one as significant, okay? Any other questions? None? Okay, if there's none, we can proceed with, there are certain rules also to follow when we try to operate or add, subtract, multiply, or divide significant figures. And mind you, as much as possible, you try to follow this rule, because moving forward, if you're taking Physics 12, and most likely your teacher is Mr. Su, I think he is trying to apply these rules here. Like if you're adding measurements, again, measurements contains certain amount of significant figures, so you need to follow them, these rules here. Like if you're gonna multiply, or let's start with multiplying and dividing. So that means that if you're multiplying and dividing, again, these are quantities, you need to round off your answer to the lowest number of significant figures in the initial numbers. These initial numbers are also given. Usually if it is a word problem, this is the given. And the thing is, you're gonna base, your final answer should be based on the correct number of significant digits or figures using this rule here, based on the given quantities. Like the given, like the height of a certain object is 30.0 centimeters, and then taking the time of 1.000 seconds. So you have to base the rules here from the given quantities. Okay, so for multiplication and division, so you follow the same rule. You try to express your final answer to the lowest number of significant figures. So that's the thing. But if you're adding or subtracting, well, in most cases, especially for formulas in physics, if you observe, most formula are in multiplication or division operation. I think you can rarely find with addition or subtraction. But anyway, if you're adding and subtracting, you will follow this rule here. So you need to round to the lowest number of decimal places from the initial numbers. Again, when we say initial numbers, these are your given. Okay,